Similarities between Fisher's and Neyman-Pearson's data testing theories. There are quite a few similarities between Fisher's test of significance on the one hand and Neyman and Pearson's test of acceptance on the other hand, namely because the latter attempted to improve Fisher's tests and thus inherited many of Fisher's ideas and concepts. Let's see the similarities in more detail. So, do both theories test research data rather than hypotheses? Yes, this is the case for Fisher and for Neyman-Pearson, so check and check. Do they use one hypothesis to perform the test? So we know that Fisher uses the null hypothesis, while Neyman-Pearson uses the main hypothesis. Actually, Neyman-Pearson even call it the null hypothesis, having inherited this concept from Fisher, but I call it the main hypothesis in order to prevent further confusion. So check and check. Is the hypothesis under test centered on 0? This is the case for both for Fisher and for Neyman-Pearson. Therefore, check and check. Do they use the same test, for example t-test, if this is appropriate for analyzing your research data? And this is the case again. So check and check. Do they use similar conventional cutoff points for assessing data, for example 5%, 1%? And we see that Fisher uses the level of significance, for example 1%, to assess the strength of the evidence, and Neyman and Pearson may use also an alpha level of 1% to assess the research data as well. So again, check and check. In the case they get the same results and they are using the same distribution, for example a t-distribution with 64 degrees of freedom, will those results be located in similar positions within these distributions? And thus the case both for Fisher, check, and for Neyman-Pearson, check. Can they use p-values for assessing the research data? We know that this is Fisher's favorite approach. Use the p-value. For example, in this case would be a p-value of 3 per mil, while Neyman-Pearson can also use the p-value to contrast against alpha level. So in both cases, check and check. Will they reject the hypothesis tested if the data fall in the critical region? That they may do so. Fisher will do that by default, so check, and Neyman-Pearson may do that as well, and therefore accept the alternative hypothesis. And if the data fall outside this critical region, can they just simply conclude nothing? And this is the case again for Fisher, check, and Neyman-Pearson may conclude that, especially if they have low power, so check as well. So what does this all mean? Do all these similarities make the two theories one and the same? Actually, even better, can they be merged into one single approach, such as the well-known null hypothesis significance testing? Let's look at it from a different perspective. Let's compare a man to a woman. So, do they have one head? Check. Do they have 2 arms? Check. Do they have 2 legs? Check. Do they have other similarities? Check. Alright, so are they the same, right? I didn't think so. So just because the theories have lots of similarities, it doesn't imply that the theories are the same or even interchangeable. In fact, the two approaches to testing data are different in timing, underlying assumptions, starting points, and final conclusions. But we will look at this in more detail some other time, in other presentations.